Here's an idea. A parabola is a graph of the quadratic function f of x equals a parenthesis x minus h close parenthesis squared plus k. Now, if the a value in the equation is positive, we get a happy face parabola with its vertex being a minimal point located at the ordered pair h comma k, where h and k comes from the actual equation. On the other hand, if the a value is negative, we have a sad face parabola that has the same vertex as before, h comma k. It's just pointing downward, and now that vertex is not a minimum point of the graph, it's a maximum point of the graph, the highest point. And so the happy face has a equals positive, the sad face is a equal negative. Now let's look at this example. H of x equals parenthesis x minus 2 parenthesis squared plus 3. You can view that as f of x minus 2, where f of x is equal to x squared, and then plus 3 on the outside. You could view it that way. So you could use translations like we've used before to see what we have here. Our basic function is f of x equals the x squared, and that's the happy face parabola with the vertex at the origin. And then we make modification. The minus 2 that's happening within the evaluation means we're going to shift 2 units to the right. When you subtract 2 from the x coordinate in the evaluation, you shift right 2 units. The 3 added at the end of the function means we're shifting 3 units up. Okay, so that means that we have our basic function, and the first thing we'll do is shift 2 units to the right, move the vertex 2 units, happy face, and then from there shift 3 units up, move the vertex up 2, 3 units, and draw the happy face, and there's our final picture. That is the picture of h of x equals parenthesis x minus 2 squared plus 3. Now we'll sketch a different variation. We'll call it g of x. It's equal to 2 times x plus 1 parenthesis squared minus 3. All right, now the basic graph is f of x equals x squared, so it's a happy face parabola with the point vertex at the origin 0, 0. The 2 in the front indicates that we're going to have a vertical stretch by a factor of c equals 2. So it's going to be stretched thin in a vertical direction. The 1 being added to the x means we're going to shift 1 unit to the left. When you add to the x coordinate, you shift to the left. And then the minus 3 outside of the function, that minus 3 says we're going to shift 3 units in the down direction. So what we actually have here is 2 times f of x plus 1, and then minus 3 outside of the f evaluation. Okay, so let's start with our basic function, the graph of f of x equals x squared. Then we'll do a vertical stretch by a factor of 2, so it'll be twice as thin in a vertical direction. Then we're going to shift that vertex 1 unit to the left, and then we'll shift that vertex 3 units down, straight down 3 units, happy face, and we are finished. This is a picture that we're drawing. The final graph is a picture of g of x equals 2 times parenthesis x plus 1 squared minus 3.